In this video, we're going to talk about graphing log functions. Using the form y equals log base a of x, we just need to graph three basic points no matter which one we are given for our base, what number we have. So we're going to graph the point a1, 1, 0, and 1 over a, negative 1. So for my first example, I have a base of 5. So notice 5 is my a. So I'll just put a equals 5. So I'm going to graph 5, 1, 1, 0, and 1 over 5, negative 1. So I'm going to go to 5, 1, and put a point, 1, 0, and then 1/5, negative 1. And then I draw my log function just like that. Let's look at this other example. So what if I have 1/5 as my base? So in that case, a is 1/5. So I still graph these three basic points that I can easily find using my base. So I'm going to graph the point 1/5, 1. I'm going to graph 1, 0. And then I'm going to graph 1 over a. So that's the reciprocal of this, which would be 5, negative 1. So if I go to 1/5, 1, 1, 0, and then 5, negative 1, look about like that, and then I draw my graph going down. So let's pick out a couple of important parts of our graph. So notice on both of these graphs, they seem to have a vertical asymptote at x equals 0. So that's an important part of our graph we need to write down in our notes. Our domain, so that's what the x values can be. X starts at 0, but it's not ever going to equal 0. It's nothing negative, so notice no negative x values. And then it goes to infinity. So we need to put 0 to infinity. And notice that's for both graphs. So I'm just going to write it one time. You're welcome to put it on both or just write it down once if you're taking notes. And then for the range, this graph goes down for infinity, and it also extends upwards to infinity. So we're going to say that the range would be all real numbers. So I just added one more thing to this video to help you connect a very important part of this. Is if we recall, so this is my person like thinking back to exponential growth graphs. Here's just that basic looking exponential growth function. Recall that our horizontal asymptote, so notice log graphs have a vertical asymptote at x equals 0 unless they get shifted. But the basic growth exponential graph had a horizontal asymptote at y equals 0. So those are opposite of each other. Notice our domain for log is 0 to infinity, where that was our range for exponential. And then our range is all real numbers, where it was our domain for exponential. And then our y-intercept was 0, 1. Notice on these graphs, that is our x-intercept. So let's put x-intercept would be 1, 0. So again, they're very much opposite of each other because these are inverse functions. Okay, so that's it for now.